let's look at number 2. For number 2, it is not in the correct form to solve by factoring. In order to solve, it all has to be on one side. So I'm going to move both of these over, and I have 3x squared. The positive 9x when I move it over is negative 9x. The positive 12 is negative 12, and now I have it equal to 0. My first step in factoring is to look for the common factor, which is what? 3 goes into all of it. We have x squared minus 3x minus 4. I am looking for factors of 4 that multiply to give me negative 4 and add to give me negative 3. So what are they?
Possible.
Yeah, so it's going to be 3x minus 4, x plus 1. When I set those equal to 0, I'm going to get that positive 4. I'm going to get that negative 1. And that is my answer. Go straight to your factoring. It doesn't have a common factor. Factors that add up to 40 and that multiply to 40 and add to negative 13 are going to be b minus 5, b minus 8 equals 0, and then set each one equal to 0. And solve. The question is, can you write it just with positive and negatives? And the answer is yes. Plus or minus 3 squared is 6, or plus or minus 3/4. Yes, I will take that. All right, so 3 has 10, x squared plus 1 equals 541. When you are solving by taking the square root, you have to get the square by itself. So I'm going to subtract the 1 first. I am going to get 10x squared equals 540. Divide by that 10. I get x squared equals 54. I am solving for x, so I have to take the square root of that. 54 does not have a perfect root, so I am going to use my factor tree. 2 and 27, 3 and 9, 3 and 3. My 3's group up, my 3 and my 2 does not. So I'm going to say the 3 comes out, the 2 and 3 stay in, so that is 6. And because I am taking the square root of a variable, I have to consider the positive and negative root. So for this one, I have 16x squared. All right, I have 16x squared plus 9 equals 18. I am going to subtract 9 from both sides. I get 16x squared equals 9. I'm going to divide by 16. So I have x squared equals 9/16. I need to take the square root of both sides. Remember, when you're square rooting a fraction, you can take the square root of the top and the square root of the bottom. So those have perfect roots. So x is going to equal the square root of 9 over the square root of 16, positive and negative root. And that is your answer.
Don't say that.
All right, so for this one, you are going to add your 9 to both sides. All right, because it's a negative. So on the left-hand side, you're going to have 4n squared equals 36. Divide both sides by that 4. I would actually not reduce here, by the way. All right, what do? Have I solved it? I have not. Why not? Yeah, I need the square root.
Can't you just put it like over 12 and say it was 12? Because 30.
So for this one, you are going to add your 2 over. 3v squared equals 120. Divide both sides by 3. V squared equals 40. Take the square root of both sides. 40 does not have a perfect root, so if you do your factor tree, you are going to see that a pair of 2's comes out. 2 and 5 stay in. So you're going to have 2 square root of 10, and it is going to be a positive and negative root. Is the quadratic formula also requires that it is in standard form equal to 0. So just like factoring requires it to be in standard form equal to 0, quadratic formula requires that it be in standard form equal to 0. All right? So you have to have it a x squared plus b x plus c equals 0. You have to have that. The quadratic formula actually only uses your numbers, your a, b, and c. All right, a, b, and c. It will work for any quadratic equation as long as it is in standard form equal to 0, okay? So even if you can factor it, you could solve it by quadratic formula. Even if you could solve it by taking the square root, you could solve it with quadratic formula. It works for anyone. However, sometimes factoring and taking the square root are easier, okay? This is typically what you would use if it doesn't have a perfect root and you have a b, all right? So if I just have an x squared and a c, I'm going to probably solve by taking the square root. Get the square by itself, take the square root. Even if it's irrational, it doesn't have a perfect root, it's still pretty easy. If it has a b, though, and it doesn't have a perfect root, it means you are not going to be able to factor it, right? And so if you're not able to factor it, you're going to go to quadratic formula. Now, this is something you're going to need to memorize, all right? So it is on the top of page 503. Ax squared plus bx plus c equals 0. A cannot be 0. Obviously, it has to be a quadratic. It is negative b plus or minus the square root of b squared minus 4ac all over 2a. That is your formula. Of things, it has to be equal to 0. If it is not, your c is going to be wrong, okay? You must have it equal to 0 in standard form, all right? And then you're just going to take your a, your b, and your c and plug it in. So let's do an example. X squared plus 5x minus 6. This is factorable. So if I were giving you this in real life and did not say use the quadratic formula, I would not use the quadratic formula here, okay? I would say x plus 6, x minus 1, right? Everybody understand that? The ones that I give you on your quiz are not going to be factorable. So, but I'm going to use this because we know what the answers should be. The answers should be negative 6 and positive 1. Because if I were to factor this, I would say, well, multiply to give me negative 6, add to give me positive 5. That should look like this. So my answers should be this when I use the quadratic formula, correct? The first thing you have to determine is it in standard form equal to 0? The answers are yes. Then I am going to say, what are my a, my b, and my c? All right, my a is the number in front of x squared. What is the number in front of x squared? 1. My b is in front of x, which is?
5.
And my c is my constant?
6.
Negative 6. So if there is a positive or negative in front of it, you have to use the positive or negative number. Had that been minus 5x, your b would have been negative 5, okay? And then you're going to take the quadratic formula, which I'm sure is negative b plus or minus the square root of b squared minus 4ac all over 2a. And we are just going to plug those numbers in. X is going to equal that answer. So let's plug it in. Negative b. B is positive 5, so I will write negative 5. Plus or minus the square root of b squared, that is 5 squared, minus 4 times a times c all over 2 times a. And then I am just going to use order of operations. That's what I'm doing, okay? All right. So, all right, take it a step at a time. Leave the negative 5 alone for right now. What is 5 squared? What is this guy? 25. Minus, what is 4 times 1 times negative 6? Why is it positive? Because I have a negative here and a negative here. Okay. And then 2 times 1 is? 2. So I'm going to leave that negative 5. What is 25 plus 24? 49 all over 2. All right. Negative 5 plus or minus, what is the square root of 49? 7 all over 2. I'm actually going to do this. I can add 7, I could subtract 7. Those are just numbers, right? So I'm actually going to do those operations. I'm going to say negative 5 plus 7 over 2 and negative 5 minus 7 over 2. Negative 5 plus 7 over 2 is 2 over 2, which reduces to 1. Negative 5 minus 7 is negative 12 over 2, which reduces to 6. Now, here's the thing. If I were given this original problem, which way do you think I would solve? Factoring. No doubt. Right? I mean, obviously. But they wanted to give you one that you could easily see what the factoring would be, so you can see that the quadratic formula works, because you are going to be given ones that you cannot factor, and then you will have to use the quadratic formula. So this is not ready for the quadratic formula at this point, all right? I have to move this 8 over first. So I'm going to say 3y squared minus 4y minus 8 equals 0. Remember, when I move it across, I change signs. Even if I were to multiply the 3 to the 8, 24, there are no two factors of 24 that multiply to give you negative 24 and add to give you negative 4. All right, so this is not factorable at all. Nor can you solve by taking the square root, because you have a variable by itself, because you can't get the square by itself because of that extra y in there. So the only way to solve this is by quadratic formula. So I want to determine, what is my a? My a is positive 3. My b is negative 4. My c is negative 8. And I am going to plug this into the quadratic formula. Negative b. B is already negative, so what am I going to write up front? Positive 4. So negative b is actually 4, plus or minus the square root of b squared, minus 4 times a times c, all over 2 times a. All right? And then you're just going to perform the operations that you have. Leave the 4 alone. What is negative 4 if I square it? 4 squared. It's positive 16. Negative times negative is positive. So this is 16. Negative 4 times 3 times negative 8. It's 12 times 8. 12 times 8? 96. And it's positive because I have a negative here and a negative here, correct? All over, what's in the denominator? Times 3, which is 6. All right? So far, so good? Just have to do what? Add what's in here. So 4 plus or minus, what is 16 plus 96? Over 6. All right, here's the thing. 112 does not have a perfect root, right? Does not have a perfect root. So I need to simplify it. I'm going to use my factor tree and I'm going to simplify it. 2 and what? 56, right? 2 and what's half of 56? 28. 2 and 2 and 7. All right. So my 2's pair up, my 2's pair up, my 7 stays in. What do I have on the outside? A 4, a 2 and a 2, right? 2 and a 2. So I'm going to go down here, right? So I have 4 plus or minus. I have 4 on the outside. I have 7 on the inside, and I have a 6 down here. I'm actually going to show you a different way to simplify than they did in the book, okay? In order to simplify your outsides, what do I have on the outside? I have a 4 on the outside, then another 4 on the outside, and a 6 technically on the outside. In order to reduce those, the number has to come out of all 3 of them. All 3 of your outsides in order to reduce. So there are two ways to reduce. I'm going to show you both ways. The reason I'm showing you both ways is sometimes you will have it reduce for one of them, but not the other. Okay? So you can split it. If it comes out of all of them, you're good. What goes into 4, 4, and 6? 2. So in order to reduce this, you have to reduce all of them by 2. Okay? So that means I need to reduce this guy by 2. What is 4 divided by 2? I have to reduce this guy by 2. 7 is on the inside, leave him alone. I have to reduce this guy by 2. This is my answer, okay? That is your answer. You cannot do anything else with it. All right? Another way to reduce, let me show you, is to split it. You can say 4 over 6 plus or minus 4 square root of 7 over 6. Put each piece over 6. This will help you if only part of it reduces, by the way. Okay? So then you can see 4 over 6 is going to be 2 over 3. And this is going to be 2 squared is 7 over 3. All right? Because you cannot reduce part of it. Had that been 3 plus or minus 4 squared is 7 over 6, you could not reduce it the first way. You couldn't reduce any of it because that does not come out of all 3 of your outsides. Okay? All right? So I just want to show you both ways. All right? They're the same answer. You basically have 2 over 3 plus 2 squared is 7 over 3. But you may leave your answer whichever way you want to. I will take either one of these as your answer. All right, I want you to try a couple of them.